Okay, well, good morning or afternoon, as the case may be. Welcome to the VAPALS OSEHRA LCAP. Have you noticed that I always rearrange those words when I do the introduction? Anyway, welcome to our call for Wednesday, March 6th, 2019. And I hope you guys enjoy our presentation today. Rick Marshall is going to get started very soon.
Yeah, right now.
Okay, great.
Hi, everybody. So this week we have some
Can
new.
I interrupt for just a second
Go right ahead.
and just remind Linda to start the recording?
I did this time. Thank you.
Okay. Just, you don't always, and so sometimes
I know.
we want to make sure we catch this because Rick talks fast.
Well, we'll see how it goes this week. So we have some really exciting stuff this week that we are not showing. As far as user-facing software, we have some great new work from Dom and the team on the intake forms for how you process people when you're trying to figure out whether or not this VAPALS ELCAP thing is right for them. But we only just got the UI part done, and so we're still thrashing through getting the back end to be completely comfortable with everything that the front end is doing. So it is not ready to present to people, and we want to make sure that Claudia and her team get a chance to look over the whole thing when we think that it's ready, so that they can make sure that we haven't botched anything in the translation. So once all three parts are there, once the UI is stable and the back end is stable and they're talking together, and we've got the sign off from Claudia, then we'll present it to you guys on this call. It might be next week. We'll see. But soon. So in the meantime, we will continue our technical discussion about how do we configure these VAPALS LCAP servers. It's partially including built into it sort of some kind of deeper stuff about how do we model system configuration in mumps and Vista generally. So where we left off last week, we had arrived at a diagram. I've modified all the diagrams a bit to punch up some of the color and contrast and to add a few things that were missing. We're going to do a quick walk back through the diagrams to date. I hear maybe somebody needs to go on mute. I'm hearing a echo coming back on the line. I can hear my own voice. So when you're not speaking, please be sure to mute. So we're going to go back through the slides we've done because they set up the punchline for this week, which is not just how have people done it in the past, but what are all the things that this model has to be able to do? The way that we configure this system is based on the idea of an abstract virtual machine. That's what insulates us from change. It insulates us from the hardware changing. It insulates us from the operating system changing. And in turn, that means that we can focus our efforts on adding new functionality, such as VAPALS LCAP. We can focus on the medicine and not on rewriting 40 years of software over and over and over with every new thing that comes out. So that virtual machine, that abstract machine that we write to, has to be as simple as possible so that we can remember it, but also as flexible as possible so that it can represent all the different things that we need to be able to do with our systems. And if we can do that, and if we can standardize the way that we name things within, when we apply this model to our systems that we stand up, then we get what we're really after here. And what we're really after here is a way to configure systems that is flexible and simple and standardized, so that we can write a new generation of automation tools to automate the installation of software, to automate the updating of patching, to automate management of these systems, all this stuff to keep the workload down, so we're not overloading VA with a whole bunch of new work, managing a whole bunch of new systems. And frankly, to make everybody else's job easier. Anybody who's got a Vista system, we want to make it easier to manage this thing by standardizing. So that's what's at stake here. That's why I'm spending this time talking about this. If we don't standardize enough, we won't be able to automate. And if the system isn't flexible enough, it won't actually be able to handle all the different system scenarios that we have to be able to handle. So what I'm going to do now is briefly walk through the slides that we did before, just to make sure that fresh in our mind. And I'm not going to spend a lot of time on it. But I'm going to do it to make sure we're fresh in our minds about the different kinds of problems this configuration has to be able to solve. And then we'll come back to this slide, and then we'll use it to show the examples for the VAPALS ELCAP project and how we've applied this model to each of them. Because I think that we've got it now. I think we have something that's flexible and simple and standardizable. But as just a reminder of kind of what we're doing, let's take about 5 minutes and go back through this. So in the beginning, our problem is that we need to have repositories that contain copies of our software that we can install on these VAPALS ELCAP servers. And in order to do that, we've got to solve two problems. One problem is how do we distribute software? And for that, we have three classes of distribution repositories: gold, silver, and copper, based on kind of how free are you. In the copper, you're completely free, versus how standardized are you. In the gold, you're completely standardized. But of course, the cost of the freedom is now you have to do everything manually. That's what we have to move away from, is kind of the copper free-for-all way we do things now, to try to get all that functionality available for how we distribute software, but using standard names and standard structures. And then the other problem that we have to solve is we want to be able to capture the running system as it is, what's in it, so that we can compare two systems and see how do they differ from each other. When you're trying to reconcile systems and figure out why doesn't the system match, why won't my patch install, it's really helpful if you can answer the question, well, what's different about this system? And right now, answering that question involves a tremendous amount of manual work. I mean, yes, there are tools to help you, but I mean, it's basically a human problem, and we got to get away from that. We got to get to the point where you can virtually push a button and have it tell you, here's why these systems don't match. So Vista standardization, Vista analysis, all of that, that's what these production repos are, these platinum repos. And distribution is what the gold and silver and copper repos are for. So we're going to come back to next week. This is what the whole arc of this thing is. This is what we want to accomplish. And then everything in between is, what do we have to be able to represent, and how do we do it in a standardized way to get us to the point where we can do this? So this week we'll do all of the run-up. So that sets us up so that next week I can show you how we name these things and how they work. Speaking of naming, so we realized that we had a bunch of things that weren't named, that didn't have namespaces or codes before, which created a problem, because if we have to be able to set, for example, on a development server, a development environment and a test environment, and maybe a copy of what's in the field environment for that side by side with each other, they can't all be named the same thing, because the names determine where they're stored. If you name them the same thing, they overwrite each other. And it's the same for our analysis server. If we want to have an analysis server that has a copy of what's at production site 1 and also a copy of what's at production site 2, they can't both be named the same thing, or else when we install production site 2 onto our analysis server, it'll overwrite production server 1. And the method for making them not match each other can't be a whole bunch of manual stuff that nobody can write automated code for. So that meant that we need to come up with naming schemas for a bunch of things we haven't named before. So among the things we have to be able to name is, what dialect of Vista is this? Are we comparing an Indian Health Server version of, say, the lab package to a VA version of the lab package? Because they're not exactly the same. So here are all of our different dialects, and here's a little naming schema that we came up with. You may remember they all start with V, and then the second letter determines your development or shop, the dialect development shop, and then the third letter is which of the many dialects that shop handles is this. So VA, for example, was originally the CAS system, so it was VAC, then it was DHCP, so that's VAD, and now VA Vista, that's VAV, except they don't exactly release that to the world. They remove some things for security purposes, and we get FOIA Vista. So this is the general overall schema, and we made sure that we had names for everything that we had to name for this. With that in place, we can then talk about the way that we talked about the way site namespaces worked, and the way Indian Health Service and VA, they had B star and A star for all of their sites. So Phoenix is APG, and Puget Sound is ARJ, and so forth, whereas IHS Phoenix is BZX. So you don't mix them up. Now we're able to distinguish not just the dialect and not just the shop, but we can actually come up with a namespace for the individual site that puts it in the context of what's the adopter. And with a site name, we can then derive a system name, so that we can start to name the computers. And naming the computers, as we're going to see, is going to be a really important part of this whole prospect, since at some point we're talking about installing repos and environments onto computers. So we talked about that schema, and we talked about the $system variable in mumps, which is a unique identifier for every system, and what does the standard require, and how have we extended that to be useful for our purposes. So now we've got ways to talk about systems. We've got a friendly little name like Avicenna that we could come up with that's pretty unique, and then we've got a system code that's nearly unique, and it is unique once you append the which mumps community are you in. We're in the Vista community, so JVV SAMI, Vista is unique across the entire world of mumps systems, whereas JVV SAMI is just unique within the Vista world, which is good enough for our purposes. All right, moving along. So with these as some basic naming schemas, we then turn to talking about the mumps virtual machines as it was originally described in the first mumps standards. And this goes back to the days when there was no operating system and the mumps virtual machine was running the hardware itself. And so all of our jobs ran inside of the mumps virtual machine. If you wanted to run mumps, you first started up the mumps virtual machine, just like the operating system starts up when you boot your computer. And then inside of it, we could segment the database and the code base into different directories, which were in different UCIs, which could be grouped together into volume sets. And this was our basic schema, is that jobs and software and data, they run inside of UCIs, which run inside of volume sets, which run inside of a virtual machine, which runs on top of the hardware. That was the model up until the 90s. And we applied that a number of different ways. So here's an example of us applying it to the old siloed software, when lab software and pharmacy software and admission software are separate, and they each had their own UCI that they ran in, and the jobs connected to different UCIs depending on what they, whether they wanted to do lab or pharmacy, and then the shared stuff would be in a manager UCI. We then talked about how the problem with that is it didn't allow you to isolate the computation impacts. So if one of these systems was under the old under that first prototype model, if lab were going haywire and we're chewing up system resources, unfortunately this impacted pharmacy and admissions and the others too. And also those computers weren't all that strong. They couldn't handle that many jobs. So as we rolled out to the hospitals, we generally siloed them completely onto different machines. So each machine had its own virtual machine, its own mumps virtual machine. And within that, we ran the jobs for that application that ran on that machine. And that was how we got started on the PDPs once we moved out of our prototype mode. We then talked about the problem that we have to be able to represent here, where you don't want to install your draft software right into your live environment. And so we have this staging approach where the life cycle allows us to stage the deployment and kind of inch our way into putting it into production. And so we have our development environment in which chaos reigns, but so does freedom. We have our test environment, which ostensibly belongs to the users, right? And they test the software that we say is ready, and then they tell us why it's not ready, and we go back to dev and fix it until eventually we both agree, okay, fine, we agree it's ready, let's put it in live. And then production is insulated from the rest of them. And again, your jobs would point to the UCI for the version of the software that you were running, right? But you had this shared UCI in between, and that caused problems when, for example, if the thing you were updated some of the software in the shared UCI, you could break the live environment. So we really wanted to really isolate them more from each other, and so we siloed them. And so it became conventional to put your development environment on its own machine, and your test environment on its own machine, your production environment on its own machine. So some runaway job in test or development would not impact production. All right, so this is the life cycle goals that we're trying to accomplish with our model. So then we had to deal with the situation where what if you need more computation than your computer can handle? What if you have more users than that? Right? It might have enough room to store your database and store your code base, but this is something, for example, that Jordan is running into. What happens if you've got piles and piles and piles and piles and piles of users? Just and what if Congress was dragging its feet about allocating a budget to allow VA to get enough hardware to handle the number of users that they had, because they were hoping the whole thing would fail? I'm talking about 1985, 86, 87, when we really needed to have an upgrade, but we went some years kind of with overloaded systems. So that's when we moved to the idea that environments don't have to be standalone. They can either replicate or translate to share their data between them, so that you can then split them across multiple environments. So these two environments are either copying the data back and forth, or one of them, whenever you try to reach for what you think is a local copy of the global, actually reaches across the network. That's what translation is, and it's accessing it over here. But it's invisible, so that the software itself that we write in mumps doesn't have to know that you're talking about 2 different machines or 3 machines or 4 machines. We write the exact same database reference that we would on either one of them, and it's up to the system configuration to say, is the copy of the data local? Is the data replicated, meaning it's copied from another server? Or is it translated, meaning that what I thought was accessing my own hard drive is actually accessing the network? We hide that, right? That's the whole point of this virtual machine, to shove that down and make it invisible to the programmer so that our code doesn't have to change when we change our configurations. So based on this kind of capability, we then move to a failover configuration. And this is the third critical thing that we have to be able to accomplish with our model. In a failover configuration, you have excess unused capacity, preferably that matches the capacity of the computer that you're using. So if your primary computer fails, it's just a matter of seconds to switch everybody over to using the secondary machine, right? And then while they're using the secondary machine, you can fix the primary machine, get it back up or get it replaced, and then put back in place the failover. And this is using the same kind of capabilities that we talked about before. In this case, replication rather than translation, so that everything that we're doing in our primary is being copied over into the secondary, and it's just sitting there passively, not used, but ready as our safety net in case we need it. And likewise, we'd have we could still have separate test systems off to the side, which may or may not be translated or replicated depending on how important they are to system operations. So several different ideas here, that we might need to have multiple environments on the same computer, that we might need to have in order to have completely different software in them, that we might have side-by-side environments that have the same software at different stages of the life cycle, or multiple environments that are backups for one another in case we have to switch over in the case of a failure. We have to be able to do all 3 of these things for a variety of reasons. That's what our model has to accomplish. So, and this all changed somewhat when hosted mumps virtual machines came along, when we started to insert an operating system layer between the machine and the mumps virtual machine. And our first concern, as you may recall from last time, was to insulate the software from that new possible source of lock-in. Right? We don't want to be locked to the hardware, so that when the hardware goes obsolete, our software goes obsolete. We also don't want to be locked to the operating system, so that if the operating system goes obsolete, our software goes obsolete. For example, DOS. You can still get DOS, but you won't find a lot of computers running on DOS. But let me tell you, back in the early 90s, DOS was hot stuff. We were real excited about DOS. And so we made Vista configurations in which Vista ran on DOS. And if we had tied Vista to DOS, then when we moved away from DOS, all that software, we would have been in serious trouble. But we didn't. We insulated it, right? We treated it essentially as an extension of the machine, as yet another thing to hide from. So that was the initial model that we did when we moved to hosted mumps virtual machines. And we applied it in a number of ways. We talked about the cluster configuration that the VA uses today, in which they can separate different kinds of computation. So all the background jobs, which can be real CPU intensive, got moved off to their own computer so that they wouldn't affect other users. The interactive users then could be on their computer so that they're not being affected by those background jobs. And then finally, we could have data servers whose whole job was to serve up the data to the other servers, just to keep up with all the network access. So this is how we came up with the data server, print server, compute server model that the VA shifted to. And then based on that, we did a simplification in which we realized we don't need those manager UCIs anymore, because if you look at this, these are more 3 copies of the same UCI than they are 3 different UCIs. So they aren't really needing to share anything among multiple UCIs. That old model, which dates back to the lab and pharmacy days, when lab and pharmacy and admissions would be in separate UCIs, had become irrelevant and we hadn't noticed. So eventually we shifted over to where there's no longer a separate manager UCI that we use for any particular purpose. We just have one environment, and it contains all our code and all our data. And in that one environment, we may replicate it or translate it across multiple servers to make sure that we're able to divide up the computation. So there's this going on in the VA. This is as an abstract level. This is pretty close to what VA is doing now on VMS, and of course converting over. Maybe nearly done converting over to Unix now. A lot of the systems have converted over to Unix. But at the same time that the VA was doing all that stuff, there was another approach to hosted mumps virtual machines that went back decades. That on platforms that the VA hadn't been using, DataTree and Greystone mumps. And in this model, instead of treating the operating system as a threat to portability, right, which is what we'd been thinking of it as, they treated the operating system as a great resource. And so rather than saying that mumps jobs run inside of a mumps virtual machine, and first you have to start the mumps virtual machine, and then you run inside of there protected from the outside, they said, oh no, your mumps jobs are operating system jobs. There is no separate mumps virtual machine that you have to start up. And instead, when you start a mumps job, it opens up the mumps virtual machine inside itself. So it's a complete inside-out model. And the advantage of this inside-out model is now your jobs can be native to the operating system. And they have access to all the things that the operating system provides, which is great because it opens up this vast, pool of capabilities. The downside of it is that it is extremely easy to write code that locks you into the operating system because now it's all there. It's all at your fingertips. And so the temptation to say, well, I know if I took longer, I could solve this problem in a way that would be good for decades to come, but I'm in a hurry, so why don't I just solve this in a way that locks me in? And, probably DOS will never go obsolete, right? So it's a risky proposition, but it's a powerful proposition. And so the question then becomes, is there some way to use this model in a way that's portable and safe so that we can get the power and the portability at the same time? That's really what we want to accomplish. The other thing that's worth noting is that under our original model, let's go to the mumps model, the routine directory, the global directory, the lock table, the input-output, these things are inside of the UCI by and large. But under this new model, the routine directory is actually a directory in the operating system. The global directory, and I've got the file name wrong here. I want to thank David Wixell for pointing this out. I didn't fix this before we got here. There's several different G files that serve several different purposes, and I happen to pick the wrong one here. But regardless of what the file name is, there is actually a global directory that is a operating system directory, which is the place where we put our globals, just like there's a routine directory, which is the place where we put our routines and so forth. So the things that we used to think of as the very most insulated from the operating system and the most inside of mumps are now inside out, the very most outside of mumps things. Mumps is now talking directly to the operating system, which has our precious software elements available at an operating system level. So if you look at these two diagrams, what you see is that they are very different pictures of the world. It is very hard to reconcile these two. So in 2000, when we were first porting Vista from an environment like this to run in an environment like this, we really tried hard not to take advantage of all the power that was there because we saw all the risks and we were just trying to safely port onto this new platform. But we knew at the time we were going to have to come back and revisit this question and figure out how do we reconceive of what an environment is and what the mumps virtual machine is, what a mumps job is, and so forth in this new world that has these new capabilities. And that had to take into account a third thing. The third thing it had to take into account is that the most recent mumps standard is significantly different in the way that it thinks about where you're storing your routines and your globals and so forth. UCIs and volume sets were never part of the mumps standard. They were something that the mumps implementers came up with. They became a convention, a universal convention. And Vista's written assuming that convention is in place. His configuration files all talk about UCIs and volume sets. They don't talk about environments. And the reason they don't is because mumps didn't have the concept of an environment as a specific kind of thing. But starting with the most recent mumps standard, it does. There are routine environments, global environments, lock name environments, and in the next standard, already in a draft approved proposal, there's device environments. And the thing about all these three things is they're incredibly flexible compared to UCIs because they don't have to match. They could be completely unrelated to each other, right? We always thought of the UCI as containing a routine directory, a global directory, a lock name table, and a device pool. And as a result, by knowing your UCI, you knew all of those things. There was a one-to-one mapping. But under the new mumps standard, there is no one-to-one mapping. You could make them all match, or you could make them all different. It's more flexible than it ever was before. It's really a radical change in the way it thinks about the world. Except for, and also the system becomes visible for the first time as an entity that we can talk about. Right? There's system IDs. That's what dollar system's about. And so a mumps job is now linking all these things together. So the problem is, how do you reconcile this with this with this in a way that allows you to handle all the configurations that we need to be able to handle while opening up the power that's here without locking ourselves into the platform, while being compatible with the mumps standard and its terminology. This is 24 years now since this standard passed, and I know, based on the way that the mumps community and Vista community used to work in the 90s, that we would have threaded this needle probably by 99 at the latest, a long time ago, if it weren't for the chaos that a number of players introduced into the mumps and Vista communities over the last 24 years. But better late than never. For VAPALS ELCAP, it's time to thread the needle. We have to thread this needle because we got to make sure that we don't paint ourselves into a corner in the way that we configure these systems. And we can't use the ad hoc systems of the past, the ways that we used to name UCIs and volume sets, because it was all manual and didn't make the distinctions we needed to make, and you couldn't possibly write the automation tools that we need to be able to write to manage these systems. And the free-for-all approach, the great power that's here, likewise doesn't solve this problem, right? Data Tree and Greystone give you the power to name them however you want, but they don't tell you how it's going to be named or configured. And so there's a lot of different pieces of information you'd end up having to save and make decisions about. So what we want to do is take the power that's here and make some standardized decisions about it in a way that allows us to represent all of the things that we used to represent in terms of different system configurations, but to do so using standardized terminology so that it's compatible with the standard. And that was the origins of the MASH virtual machine. MASH stands for the Mumps Advanced Shell. The name was coined by David Wixell, who's either on this call or will be listening into the recording of it. And it was, the intent was, we knew that we wanted to create a standardized set of library tools, system administration tools, and programming shell tools that we could install on any mumps environment that's not dependent on Vista in any way, that could be slipped in underneath Vista or Epic or any other such system to make sure that people don't have to reinvent the wheel and always have a rich toolkit available to them. And as part of that, we came up with the idea of MEEP, the Mumps Enhanced Environment Project. And the idea of MEEP is to solve this problem. How are we going to configure these systems in a standardized, predictable way so that we can write automation tools? That's what the MEEP initiative is about. So what we came up with is the following. If you compare this to the earlier abstract models, I'm just going to jump back for a second, all the way back. Just a quick flash to the original mumps virtual machine, right? Just fix that in your head. And remember, when we moved to the hosted mumps virtual machine, all we did was slide the operating system underneath, and we didn't do anything else. There was no other significant change, which means that fundamentally, we've been operating off the same mumps virtual machine for many decades now. I mean, this goes back to the 70s. This one here only goes back to the late 80s, but ultimately this isn't much different from the one that goes back to the 70s. So this virtual machine makes some significant changes. And one of the changes it makes is it recognizes that we do have all this flexibility available to us, right? These different kinds of environments defined by the standard, which can represent different elements out in the operating system, like GTM and Data Tree did. But we're not going to do that. We're not going to use that full power. We're going to tame it. And we're going to say, notionally, we're still going to have an idea, like the MUMP standard does, of an environment. And the environment will map to what we used to think of as a UCI, except that the difference is that you get to define where's the routines in the operating system, where's the globals in the operating system, and other kinds of things that they didn't talk about. Where do our system administration scripts go? Where do our web interface files go? Scratch files. What about our repository libraries? Where do they go? So we make a bunch of configuration decisions like this, and we decide it once for the entire environment, and then we treat it as a whole. Even though these things are real and the UCI isn't, the UCI is notional now because we're running out in the operating system, we're still going to assert the idea of an environment so that we match the standard. And we're going to map it to the old idea of a UCI so that we can figure out how to make all of our old configurations, our flexible scenarios that we have to be able to handle using this idea. And then because you might have to have multiple environments on the same computer, as we saw for a number of different reasons, we're still going to have the idea of a volume. We won't call it a volume set anymore. It's redundant. We'll call it a volume. And a volume is a collection of environments that are closely related to each other. So for example, if you're a production site, you might have within your production volume, you might have a live environment and a test environment and a dev environment. And we might do similar kinds of things for our development machines. We might have, and then we might have multiple volumes on the same system because we might be developing version 18 of VAPALS ELCAP in one group of environments. And then at some point, there'll come a turnover where we need to start working on version 19. And so we open up a new volume and set up a dev UCI in it, and that's where we'll start working. So that system might then have two volumes on it, one for 18 and one for 19. And within 18, it might have the full rich set of a dev and a test and a field environment. Whereas in the version 19 environment, we might not have got that far yet. We might only have a dev environment. We might just be getting started. So this idea of kind of the flexibility that we had under the old configurations, you can still represent it as long as you do the mapping that says, where do these things go? And we don't want to do these mappings manually now. We want to do these mappings in a standardized, automatable way. So that's one big difference. The volume set doesn't really exist. The environment doesn't exist, but we're going to behave as though they do because it simplifies everything. And now, like the data tree and Greystone model, we're not wrapped up in a virtual machine the way we always used to be, a mumps virtual machine. We're wrapped up inside the operating system. So when we look at our model, the operating system is the wrapper around the volume and the environment and the job, right? Which means that, like data tree and Greystone, we're saying that our virtual machine runs inside of the mumps job. It's no longer the big container that is our operating world. We're now native to the operating system. We run natively. But when it comes time to interact with the operating system, we're going to limit the ways we do it. We're going to use standard tools and standard libraries built in MASH that hide from us. For example, the syntax of directories on VMS is different from the syntax of directories on Unix. So we're going to hide the details of the directory specification, right? We'll just do a call into a standard MASH library. If we want to get the contents of a directory, we'll ask MASH for the contents of the directory, and it'll give us the contents. Then we don't have to worry too much about the fact that the syntaxes don't match. The other thing that's important to note here is that we, unlike the standard mumps model, we recognize that the system may have multiple servers, right? So in a failover configuration, our VAPALS ELCAP systems that we are standing up at Phoenix and elsewhere have two different servers on them, a primary and a secondary. And the users will mostly be using the primary, but if the primary goes down, that way they can flip over to the secondary with very little downtime. But we still need to be able to talk about the thing as a whole. So the thing as a whole is a system, and the individual servers within them are called servers. And that matches the terminology that we've been using forever. Okay, so this is an abstract model. The question is, can this abstract model represent all the scenarios that we have to be able to represent? We're using VAPALS ELCAP as our example to test out this new model. So here's what we've come up with so far. Here are the main examples that we can think of from what's coming up with our deployment to the VA. The first thing is, this is a typical VAPALS ELCAP server, the Phoenix server. And it involves the system involves two servers, a primary here and a secondary down here. And on the primary, oh, and by the way, we talked last time about job numbers and how they derive from the system, dollar system value. They're related to each other. So your job numbering 1, 2, 3, 4, 5 for one computer, it could be 1, 2, 3, 4, 5 for the other. But if you have multiple environments on the same computer with multiple users, they're coming out of the same pool. So if we had a test user here running off this test environment, for example, he couldn't be job 1 because job 1's already taken. It's been assigned over here to this user, to this production user. So the counter, the pool of job numbers comes from the server that you're on, what mumps calls the system. So we got a primary and we've got a secondary, and our idea, which we got some serious help from Dave Wixel and others in fine tuning this, is to say that the primary will run the live environment, which will be replicated over to the secondary, so that if the primary goes down, the users can switch over to the secondary. But our test environment, when test users are running, that will be their primary. They'll run on the secondary, what we think of as the secondary server. And that way, testing won't interfere with production, right? And so this test environment will be replicated back up to the primary, which means nobody will ever do testing on the primary and nobody will ever do production on the secondary unless the primary crashes, in which case everybody shifts to the secondary. So this model works pretty well. It gives us a way to talk about things. We've now got, if you look at these directory names, right, the name of the live environment's location in the operating system is different from the name of the test environment's location. So they won't overwrite each other. We've come up with a standardized way of naming them to keep them apart from each other. And we name them the same on the primary as we do on the secondary so that the replication works. And otherwise, it looks like this works. The model extends very nicely. It maps very nicely onto what we want to do for our VAPALS ELCAP servers within the VA. So at present, this is the model that we'd be applying. So we'd be calling the overall VAPALS ELCAP system ACML with the code APG SAMI. But the individual primary and secondary, the primary would be ACML1 or APG SAMI1. And the secondary would be ACML2 and APG SAMI2. And if we ever needed to extend the cluster for any reason, we just keep doing that, right? And that way, it's really clear they're part of the same thing. They're the same overall server, same overall system. So you can see how this really maps onto this, right? As long as we answer these questions in the configuration, the environment has a kind of reality, and it has enough reality that we can treat it as a real element here. Even though Unix doesn't know that's how we're using that directory, we do. So it has that much reality. All right, so let's try some other examples. Here's another pair of servers. Here's Avicenna, the server that we have now, which is where we're doing our development, this system. And right now, we only really have one environment in it. And the way that we have the environment named, as you're going to see in a couple of slides, doesn't yet follow this model. But we have to move to this model. The way that we have it named right now is /home/OSEHRA. That's the root directory where we're storing all the information for Avicenna, where we do our development. And the problem is, if we now want to stand up a test environment next to it, well, the way that we do things right now, we would name it /home/OSEHRA, and that would overwrite. It would overwrite our dev environment. So we got to get away from that. So if we're following our model, which we'll talk about in more detail in a moment, we name the volume set something that allows us to see that this is a VAPALS ELCAP volume set, and that it's responsible for the development of version 18 of VAPALS ELCAP, and which dialect is this associated with? This is associated with the VAPALS dialect. So that later, when we open up our version 19 volume set, its name is slightly different. It's close, so it sorts together, and we can see that it's related. But the 19 discriminator makes it clear that when we've moved on to the next version, so we don't have any confusion about that. And then the individual environments within it, dev, test, and live, or sorry, dev, test, and field, which is our where we'll have a snapshot of what's currently installed in the field out in the VA for reference to compare against what we're developing and what we're about to send out. Their names are, again, very close, but they've got this little prefix for the UCI name that tells us the difference between dev and test and field. One of the things about Unix that's really handy is that when you're typing one of these directory names, you can hit the tab key at any point, and if the rest of the file name, if you've only entered part of the name but the rest of it's unique, it'll fill in the rest of the name for you. So this whole thing is designed to make it to as quickly as possible get you to the unique part of the name, so that you can hit the tab. So really, to get into to change directories over to where the test environment is, I only have to get as far as TST and press tab, and it'll fill in the whole rest of the -JVV, SAMI, and so on. So we're trying to make it quick and easy to move between environments with this naming schema that we're coming up with. But at any rate, other than the fact that it's got multiple environments and multiple volumes, really Avicenna is pretty simple. We don't have primaries and secondaries. We don't have it set up with failover. We're not treating it like a production environment. We have backups. So if our system crashes, we can restore, but we'll have some downtime, which is acceptable because we're not running live patients, right? We're not running live users taking care of live patients. It's not as essential that it be up 24/7. It'll be up close to 24/7, which is good enough for us. Which brings us to the problem of when it comes time for us to test the software, there's only so much testing that we can do in our test environment, because this test environment right here doesn't exactly look like the actual operating conditions that the software's got to be installed into. This is the target system, and this is our development system, and the mismatch is big enough that it could cause problems. So we actually need a field system that represents what's actually in the field as closely as possible so that we can find out if what we're doing is going to work or not. So we need to stand up Gaber. And Gaber is going to be our field system that emulates the way that the VAPALS ELCAP servers will be set up inside of the VA, but with a couple of modifications. And one of the modifications is if the testing is happening in what were the live and test environments under this model, right? This is the live that we'd be using, and this is the test we'd be using. Then our problem then is it won't take long before there's a difference between what we say is live and what's actually out in the field. So for the sake of convenience, we'll keep this extra field environment here that's a copy of this one. And it just sits here with a copy of what's actually in the field, so that as we're testing something in here, if it breaks, we can always compare it to see what's different or restore from it if we need to, if that makes sense. And likewise, there's going to be a little bit of fiddling that we have to do with the software before we release it to VA. Anytime that it interacts with the security software, right? We talked about how the VA strips out the security software before they release to the FOIA. FOIA Vista is the basis for OSEHRA Vista. OSEHRA Vista is the basis for the VAPALS dialect that we're putting on these VAPALS ELCAP servers. In fact, our VAPALS dialect is almost exactly OSEHRA Vista with some additional community contributions. So that means that what we have doesn't exactly match what the VA has. And the security software that we don't have in OSEHRA Vista or FOIA Vista is one of the things that we have to be able to test that it works correctly. We have to be able to make broker connections from our VAPAL server to what we believe is a VA environment. And the broker is going to try to sign in, and that it's going to be using the encryption that the VA uses in-house. So if one side is trying to use the VA encryption and the other side is not using the VA encryption, it's safe to say that it's going to say you're not a legitimate user. I have no idea what access code or password that is. So, no, you can't sign in, and suddenly our software doesn't work. So the other purpose of Gaber is to give us a place where we can have, you see how it says VAV here? That's the dialect code for VA Vista. So this software isn't exactly going to be the same as this software. It's going to be our development software as modified to reinstall the VA security software. Here, here, and here, so that we can try to do broker connections, and hopefully, if they both encrypt and decrypt the same way, we should be able to make a connection and get access to the system. And that means if it does, then that version of the software is then what we ship to the VA and use to create the snapshots that stand up their servers. Right? And likewise, when we do patching, if that patching intersects with their security software, then we release it out of here where we have the security software, not out of here where we don't, because OSEHRA Vista and FOIA Vista don't have that security software. So you see why this has to be a separate server for two different reasons, so that we can test the client-server primary-secondary relationship, and so that we can test the security software that the VA is using, but that nobody else outside the VA is using. But again, if you look at this is the same model, just extended. All the ideas that are right here captured in this abstract virtual machine model can represent what we've now described as three different configurations. One for our development, one that'll be installed in the VA, and one that simulates the VA plus two additional environments so that we can do our testing correctly. So far, so good? Let's go to our fourth example. Our fourth example is, how do we manage the patch stream, right? A big part of this that's easy to overlook is that Vista is a moving target. The software is constantly changing. There's constantly new patches coming out from the VA that we need to turn around and then install back into these VAPALS ELCAP servers inside the VA. There's also innovations coming from the OSEHRA community. in Osehra Vista that we need to be able to put in. There's also ongoing improvements and bug fixes that we're going to do. Once you have, when you first stand up a VAPALS ELCAP server or any other system for the first time, you can use a snapshot of an environment to do it. It works great. You're just Xerox copying. And then as long as you run some configuration stuff to rename things properly, you're good. You've got a running system. But once you have a system that you rely on that's in use, it can never really benefit from a snapshot ever again. Because if you overlay it with a snapshot, you've just erased all your patient data and all the other data you've been accumulating. Snapshots are good once for standing up production environments. And after that, if you want to update, you can't use snapshots anymore. You need a stream of incremental upgrades. And VA has a process for doing that with a forum system and patching. And outside of the VA, people have been sort of simulating that by hand manually, right? But they don't have a forum system stood up that actually does for the rest of us what VA's forum does for VA. So a whole bunch of the automation is missing outside of the VA. And on top of that, because so much of it's being done manually outside the VA, it means it's being done in ad hoc, very free, liberated, and therefore that means real human labor intensive, expert human labor intensive ways, which is exactly what we don't want for these VAPALS servers, VAPALS ELCAP servers inside the VA. They need to be done in a standardized, automatable way so that somebody like Ardit, who hasn't spent the last 40 years patching Vista systems, can nevertheless sign into these things and run a script or two and have it do all the updates for him. The only way that's going to work is if we shift from the manual ad hoc ways of patching that people are doing outside the VA now to a real standardized, automatable way of doing patching, like the VA, but even more standardized than they are. Right, so we're going to need to be leveraging some of the work that's happened over the last 5 to 6 years in the Osehra community to extend the VA forum software to make it even more standardized and even more automatable. Fortunately, we have that software thanks to the Osehra community, and we're going to apply it here for the first time. We're going to stand up a forum-like system, and it's going to be side by side with reference environments to show us what does FOIA Vista look like, what does VA Vista look like, or as close an approximation as we can manage. What does Osehra Vista look like? What does the VA PALS dialect, which is nearly Osehra Vista but slightly different, look like? And then just for completion, what's the World Vista environment? We could put other ones on here as well. But the point is, once you've stood that thing up, then you can have an environment in which we could do development of patches, incremental upgrades in Avicenna, and we could send them to our forum environment. And forum and the patch module can handle patch testing before things are released. So it could say, we're going to do our testing on our field system, Gaber. So it could push the software over to Gaber. We could test it out, make sure it works, get it refined, and then if it involves some of the security software that we can't release to the community, we'd release it directly from there as in a distribution. Might be on a USB drive, might be in a file that Ardit can just copy across using SSH or FTP. We can work that out, but at some point it comes up with a package that has a release that he can then install onto the ACML system, run a few scripts, and have it install itself into the ACML environments. So now this is a really different purpose for this set of environments and volume sets than the ones we've seen before. And it's got a different relationship to the different systems. But still, it's the same model as the abstract virtual machine, right? There's no more mumps virtual machine on the outside. There's just the system on the outside, and the system can have one or more servers, in this case, one. Although someday, if this becomes really important, if forum becomes really useful, then we may need to do a primary-secondary arrangement on it, just like we do for the VAPALS servers inside the VA themselves. So this can expand, but it's got to have all these reference environments, and it's got this one environment that talks to a lot of other systems fairly intensively. So this is different from the others too, and yet the model works for all of them. So we think that we have a stable, useful model here for how to represent the abstract machine that you write mump software for in a way that's automatable and portable. Based on that, right, that finishes the talk from last time and brings us up to the present as far as this is, as we understand it, the model that we're going to use and the kinds of things that have to be named. So now we could go back to where we were in the beginning when we started to say, well, what are the components of the names? How do we name the different elements of the system and of the software? So we've talked about dialects. We've talked about the developer/development shop that's responsible for a dialect. We've talked about how you name an adopter, how you name a site, how you name a system. So now we can move on and say, now that we know what a UCI is and what a volume is and what an environment is, we can talk about how we name them, which gets us closer to being able to name our directories and our repositories, which is what our final session next week will be about. So let's take the last couple of minutes here and kind of show where this brings us. So we're staying very close to the way we used to name UCIs. We're giving them very short names, but we're not going to do this VAH stuff anymore. You're not going to be coming up with a generic UCI name. You're always going to name not that generic, because VAH just stood for VA hospital. That's a little too abstract. We're going to say that the UCI name says where you fit into the software lifecycle. What is your role? I mean, what level of safety does this environment need? So that's something that you should have in mind before you ever install software into an environment, right? I mean, any experienced Vista person who has managed a system will tell you more than once they dropped what they knew was volatile software into what they thought was a development environment, only to discover that it was actually the production environment and they broke everything. We've all done it. If we've been around long enough, it happens. And the reason it happens is the VA names all their environments VAH. So you can't tell from the name what that is. So we're going to say live if it's a live environment. We're going to say test if it's a test environment, dev if it's dev, and so on. So you can tell just by looking at it what the potential impact is of changes to that environment. And we're going to keep them short so that it's quick to type, so that you can just type that much and hit tab, and that should be enough to get you the tab completion when you're trying to specify a directory listing. And then in parallel with that, we've now got this idea of volumes where we're no longer, since the beginning of time, volume set names in Vista have been complete dummies. ROU for routines was the name of the first volume set that the first guy set up the first time he tried to stand up a basic mumps environment with the thought that maybe someday this would be Vista. And because that generic name ROU got stamped out over and over on systems all over the world, they're all called ROU. You literally can't tell from the volume set name whose this is. And Cameron Schlehuber thought that was a problem, so when he stood up his Platinum environment for releasing software to the rest of the world through FOIA, he named it PLA to make it different. But what happened next? Well, everybody copied his PLA environment and stamped that out all over other environments. So inside the VA, all the environment volume sets are named ROU, and outside they're all named PLA or something similar that's equally generic. This is not helpful. These volume set names are not telling us what we need to know. If we tried to put two of these things together and name a directory after them, they'd overwrite each other. So we're now going to have volume set names that say, whose is this and what is this? So if you're VA Phoenix, you have a site namespace of APG. So it makes sense that your primary volume set that most of your business is based on would be named APG, right? But if you had some secondary volume set that was about just one application, like VAPALS ELCAP, whose namespace is SAMI, then it would make sense that your volume set would be APG SAMI. That way you would never mix up whether you were working in your live Vista environment, which was APG, or your live VAPALS ELCAP environment, which is APG SAMI. The volume sets have different names. And likewise, we could compare Puget Sound's VAPALS ELCAP environment, which would be ARJ SAMI, to APG SAMI, and know which one was which as we were looking at them. Or we could drop ARJ in there and say, well, what's in Puget Sound's main Vista environment compared to what's on the VA Phoenix VAPALS ELCAP environment? The names are all unique now under this naming schema. You can tell immediately what you're looking at. So that handles most of our environments, but not most of our cases, as typically the majority of cases are handling special circumstances. So let's take a quick look at them. We have Gaber, which has a VA field environment that stands in not for specifically Phoenix or Puget Sound, but for all the VA environments, right? It's our staging area for testing stuff before we release it to VA. So it's not specific to any of them. So how do you name that? Well, it's got to start with JVV for reasons that are down here. And the reason is J is the namespace for non-federal sites, and VV is the dialect source for the Vista Expertise Network, which is what's hosting this project within the Vista world. So the JVV part is essential because it's a VAPALS VEN environment. But what comes after that? And so we remember that all the namespace for all VA sites, if we go back here, is A, right? ARJ, APG, etc. So if we need a universal name that stands in for all the sites, it could be A. And also, just as a nice side effect, we get VA hidden in there because we happen to have a V at the tail end of our dialect name. So JVVA is the volume set name for the Gabor machine. If we go back to Gabor and look, sure enough, there it is, JVVA, right? And our reference environments could be in volume set JVV ref. It doesn't really matter then. The volume set name needs to be unique and suggestive. And for reference environments, it's not as tied to any particular application or dialect or anything else. So we can just use a generic name as long as we, the VEN who manage the JVV namespace, keep track of our names and don't assign JVV ref to anything else. It could be unique, right? As long as we just have a little listing of them. Our forum environment, which is on the Hopper system, we could call it JVV hop. It doesn't matter. There's only one of them. It doesn't need to follow a pattern other than that it needs to be namespaced and not collide with other names that we've assigned. So let's turn to something more interesting. What about Avicenna? Well, we talked about this idea that you would build a name construct with multiple parts that, first of all, has the JVV SAMI to say SAMI because this is about the VAPALS ELCAP, JVV because it's our system, and the 18 is because it's version 18, and the VVP says that the target dialect for this is the VAPALS ELCAP dialect. One of the things that's really missing in the world, I think just generally in the Vista world, when it comes to trying to figure out when you're writing software to improve Vista, is people too often don't think about, well, which dialect of Vista are you improving? Because if you don't say which dialect of Vista it is, you're sort of implying that anybody could install it. And that's often not the case. You're often thinking about the VA software and not the IHS, or vice versa. You might be developing software for IHS that you aren't thinking about whether or not it'll run on the VA. We need to start getting smarter about saying what our target dialects are so that we know not to install it if it's not for our dialect. And if we do that, and if we have simple diagrams that show the relationships among the relationships among dialects, then we could tell just by the name that if this is for VAPALS ELCAP, it might also run on OSEHRA Vista, which is very close to it. Which means it might also run on FOIA Vista, which is also very close to it. You could sort of gauge the distance your dialect is from the target dialect and make a gut feel estimate of, what's the likelihood that this could run on that dialect or not. Whereas right now, we don't even say what the dialect is it's for. It's just like terra incognita. This will run for somebody. Good luck. Maybe it's you, maybe it's not. Maybe it won't run on any dialect except the one I have on my little laptop here because I never thought about it. This has got to start becoming part of the world. And it doesn't cost us anything to tack it onto the end because remember, a volume set name, you just start at the beginning and hit a tab and voila, it does tab complete. We're relying on Unix tab complete to finish these names for us. A couple more simple examples. For my laptop where I do MDC development, it could be KBAF MDC because KBAF is my namespace, my personal hard hat namespace, and MDC is the dialect for MASH and other MDC things. But if VAPALS ELCAP ever stands up a server to do MASH development, which we haven't done yet, we've been developing in Avicenna, then we could call that JVV MDC. And that way you could compare the two environments and know which one was which and not get confused about, what are you comparing. If we have a George Timpson FileMan environment, the George Timpson version of 22.2 doesn't exactly match the VA version of FileMan 22.2, which doesn't exactly match the MedSphere version of FileMan 22.2. What should have brought them all together instead caused extra fragmentation in the code base, which is just a bit of a little disaster here. But now you could name the environments and put them side by side. You just put the VST suffix at the end of the George Timpson version. You could put the VAF suffix for the VA FOIA version, and for MedSphere, you could put the VSO, right, for MedSphere Open Vista. And now you can sit them side by side, and you don't have any risk that you overwrite each other. So this is the general idea for the schemas, and this shows you where they come from. Finally, to wrap up, with all that done, we can now answer the question, how do you name the environment? How do you name the directory where the environment lives, right? So an environment named liv, APG, which would be the VA Phoenix Vista Live environment, would have a home directory of liv-apg, which fits the syntax for Unix directory names. Whereas Avicenna's dev environment would have this name for the directory. And again, the length doesn't matter as long as the part that's unique at the front is very short. Because what's this going to be sitting next to? It'll be sitting next to test and field. It's not going to take a while to get to the unique part. So that's the home directories. That's the environment names. Finally, for today, the home path. At present, all these environments are named OSEHRA, right, at present, and obviously that's something that we're going to fix. And they're under /home/OSEHRA. So what we're going to move to in time to do the verification, the certification by OSEHRA and the install at the VA is we're going to keep it under the home directory, but we're going to rename it to be the name of the volume of the environment, dev-jvv SAMI-18.0-VPP. So that would be our OSEHRA environment, our Gaber environment, the field environment, release environment would be rel-jvva. That's what would be shipped out and installed by Ardit onto the servers at Phoenix. And then when he run the scripts, they would rename rel-jvva to be live-apg SAMI so that they become the environment for Phoenix, right? And the name says so. Someday, we're talking about moving to a more standardized model. The home model we developed early on, we know it works. It's worked in many production environments, but it's not actually very Linux standard. It doesn't follow Linux's standards and conventions for where things go. So someday we might move it to var/db/meep/ the same thing. Whatever this little prefix is, the kind of route path to get you to where your home begins, this can change over time. But the important thing for now is that we get the volume, that the directory name now becomes the environment name, transmogrified to replace the comma with a dash, so that you can tell when you look at a directory what environment is contained in that directory, which you can't tell right now. That's part of the process of getting to where we have automation tools to take care of all this for us. So I know we ran through a lot of stuff. A chunk of it was just going back over the past to get us ready for today's presentation so that you wouldn't be too confused when you see it's all starting to gel into place. And for next week's class, we can talk about now, we're going to do a deep dive into one of these home paths and say, here's the new standardized model for how you name the subdirectories underneath the home directory for an environment. And here's how you name the repositories that are derived from those directories. That's the final piece to being able to talk about where is the software going to be when we hand it to Ardit and say it's ready to install. It's going to be in that configuration we talk about next week. Thank you, everybody. I'll pass it back to Linda here.
So have a great day. As usual, let us know if you have any questions. I will put this up, if not in a couple hours, then tomorrow morning at the latest. Well, maybe tomorrow afternoon, but very soon. Have a great day, and thank you.
Thanks, everybody.
See you guys.